All right, ladies and gentlemen of Algebra 2, we're going to talk a little bit today about the properties of logarithms. So remember, a logarithm kind of works with exponents. It's kind of a way to break down exponents. So it might be a good idea to look at 10(1) or 10(2) just so you can remember what's going on here. So we got to look at some of the properties of logarithms and then how do we use that to solve equations with that. So start with this. So remember how, like, when you're multiplying, you add exponents. So you go 3 to the 2, 3 squared times 3 to the 4th is actually going to be 3 to the 6th. So you'd add those two up. All right, so logarithms kind of work like that. Remember, logarithms are exponents. So if I've got two things that are being multiplied here, I can write them as a sum. Okay, so just like I did up here, this would be like 2 plus 4. Logarithms are an exponent, so if it's multiplied, I can add. So if I'm looking over here, this could be rewritten as log base 3 of 2 plus log base 3 of 4. All right, so that is one way I can rewrite that. So if it's multiplied two things, you can rewrite it with addition. So log base 4 of 2 is that, log base 4 of 3 is that. Figure out what the log base 4 of 6 would be. Well, realize that log base 4 of 6 is actually equal to log base 4 of 2 times 3. It's amazing how factors come back into play all these classes later. So if there's multiplication here, then I can take log base 4 of 2 plus log base 4 of 3. So that would be 0.5. That's going to be 0.7. Oops, sorry, I don't want that equals. That's going to be plus 0.79248. So I'm going to add those two, 0.5 plus 0.79248. So my answer for log base 4 of 6 is going to be approximately 1.29248. That would be my answer. So now if I go use log base 2 of 3, equal to that to approximate the log base 2 of 48. Now, here's where you kind of got to get clever and remember a couple things about logs. So log base 2 of 48, I can split 48 into 16 times 3. Okay, so 48 can be 16 times 3. So that would be log base 2 of 16 plus log base 2 of 3. Now the log base 2 of 3, we've been told, is 1.585. All right, so log base 2 of 16, gosh, where are we going to get that? Well, realize that this is saying what exponent goes on 2 to get 16? Well, what exponent goes on 2 to get 16? Well, 4. 2 to the 4th equals 16, so the log base 2 of 16 is going to be 4. So if I add 4 plus 1.5850, my answer is going to be approximately 5.585. So don't forget kind of how all this works, because it's 2 raised to that power. So how can I solve with this? I'm still going to use this property, except I'm going to go a step further with it. So now I'm going to kind of work backwards. If that's addition, that means I can put this and this together. So I'm going to have, let me change color here so it's a little bit better. That's not better. So I'm going to put this all in one thing. Log base 4 of x times x minus 6 equals 2. So now remember what this says. This says x times x minus 6 is equal to 4 to the second power. That's switching it into exponential form. All right, so it says this, remember exponential form says this raised to this exponent gives you that. Okay, so that's going to be x squared minus 6x equals 16. Now it becomes an algebra problem like you've done 100 times before in your life. Bring 16 over, subtract 16 over. So that's going to be x minus 8, x plus 2. So x will equal 8 or negative 2. So x is probably going to be 8 because a negative would give me a negative answer, and that's not going to work. So that's kind of how that comes into play. So if I take a look here, let's kind of put this together. So that's going to be log of 8 of x times x minus 12 equals 2. So x times x minus 12 equals 8 squared. So x squared minus 12x equals 64. Bring that over. So what times negative 64 gives me negative 12? I'm going to go with 16 and 4. So that's going to be x minus 16, x plus 4 equals 0. So x is going to equal 16 or negative 4. But negative 4 is not going to work, so I want 16. That's my answer. But notice, all I'm doing, putting together what it's going to be, then I take 8 to the second power and I go from there. So now, switching gears, quotient of powers now. We've talked about this before. When you are dividing, you subtract the exponent. So you take 3 of 4 minus 2, and that's going to give me 3 squared. If you think about what these two things actually represent, I really hope that makes sense. You know, 3 to the 4th is 3 times 3 times 3 times 3. 3 squared is 3 times 3. So that cancels. You'll get 3 squared. There's my answer. So that's kind of how that works. Now for logarithms, it's the same kind of idea. So you have a division problem. So you take 4 log base 3 of 4 minus log base 3 of 2. That would be my answer. That would be my rewritten simplified version. So if I look at this, figure out the approximate value of the log base 3 of 4. Well, log base 3 of 4, this is where you got to get a little clever. Log base 3 of 4, I could rewrite that log base 3 of 20 divided by 5. Okay, 4 can be rewritten as 20 divided by 5. That's fine. But that can be rewritten as log base 3 of 20 minus log base 3 of 5. Well, log base 3 of 20 we know is 2.7268. Log base 3 of 5 is 1.4650. So now it just becomes a decimal subtraction problem. So my answer is approximately 1.2618. There's my answer. Power of powers. Basically, remember, this is where you would actually multiply. So that's 3/5 times 3/5, which is going to give me 3 to the 10th, which is the same thing as 5 times 2. That's where my answer is. So now, how does that work to logarithms? Well, in logarithms, if I've got power to a power, all that means is I get to move this out front. That's how that works. All right, so this would just be 2 log base 3 of 5. That's all that is, 2 times log base 3 of. So now, you use log base 4 of 6 equals that to approximate the value of log base 4 of 36. So now I'm hoping that you're getting kind of clever here and recognizing that the log base 4 of 36 is another way of saying log base 4 of 6 squared. So now log base 4 of 6 squared means I can move this out front. So that's going to be 2 times log base 4 of 6, which we know is 1.2925. So 1.2925 times 2 is going to give me a grand total of 2.585. All right, so now we can use these and we can kind of help us solve some equations here that have some elements in it. All right, so now if I take a look here, I can start kind of putting these together. So I can combine the logs, cancel logs, and then solve. So the first thing I want to do for this is realize that if this is out front, I can put it back here. So I can rewrite this as log base 5 x to the third minus log base 5 of 4 equals log base 5 of 16. So now if this is subtraction, that means that this is log base 5 of x to the third over 4 equals log base 5 of 16. So now the logs kind of basically cancel out. So I'm left with x to the third over 4th equals 16. So that means x to the third equals 64. So if I take the third root of 64, I'm going to get 4 for my answer. So that's what x is going to be, 4. But notice, I combined everything into one log, got rid of the logs, and then solved. So if I take a look here, I can rewrite that as log base 2 of x to the 4th. I'm going to move this back up, minus log base 2 to the 5th equals log base 2 of 125. So same kind of idea. That's going to be log base 2 of x to the 4th over 5. I know it's kind of weird that subtraction is division, multiplication is addition, so it's kind of weird that way, but you got to trust it because it is, like I said, an exponent. So all those rules come into play. So logs cancel. You have x to the 4th over 5. That's a 5, despite what my penmanship looks like. So if I multiply this, I'm going to get x to the 4th equals 125 times 5, which is 625. So then look for the 4th root, and that's going to give me 5 for my answer. All right, so that's all I'm doing, just trying to combine them into one, okay, using the rules that we talked about, and then solving. So take a look at this one, a little bit different now. So this side will be now log base 7 of x squared. Move this back over. Now these two together would be log base 7, 27 times 3. 27 times 3 is going to be 81. So I have log base 7 of x squared equals log base 7 of 81. So x squared will equal 81. So I'm hoping you guys know this one. X equals 9. Boom, thank you for playing. So play around with it. Come talk to me with questions, all right? And we will talk to you soon.